Right, and we are live. Anton, over to you.
Cool. All right, so today we're gonna talk about the evaluation and monitoring and also um, prioritization. In my opinion, evaluation and monitoring is very, very important topic because what is the point of learning all these agentic design patterns if we cannot, um, measure them? I'm talking about evaluating agents, evaluating prompts. And this is really because I'm a software engineer, this reminds me a lot just software testing in general. There are so many different types of testing and with the LLMs and agents, because agents are built on top of LLMs. I'm thinking about black box testing because of the probabilistic nature of these LLMs. I think it's even more important to have some numbers so we can see these numbers and compare them. And this chapter goes through different important topics describing the whole process of evaluating and monitoring agents in production. And it starts from the performance tracking. Um, in a real life, when running these agents in prod, you would like to see accuracy, latency, resources usage, because if your chatbot or something is taking too much time to answer, you will not have a happy users. And there are a lot of different products and frameworks allowing you to nicely integrate these observability tools into your code base. One of them is LangFuse, for example. And this is how observability looks like in LangFuse. You can see all the different like kind of metrics. Um, uh, if any personal information was detected in prompt, how much time it took for each step in your pipeline to process the request, etc., etc. Token usage is very important because GPUs are expensive. There is a cost. Um, well, LLMs are expensive to run on these expensive GPUs. Everything is there is a shortage right now, a severe one. So there is a budget that definitely exists, and you have to track how much you're paying for each request. And this also allows you to um, do optimizations and improvements. For example, you can modify your prompts for your agents, make them shorter, ask agents to provide shorter answers. This way, you can optimize your costs. And this is also a screenshot from the lang views. Then there is a big topic regarding the prompt management. This is also very important because in real life you cannot really build a successful product without putting your prompts into some kind of versioning system, at least Git. And popular programs, platforms like LangFuse, they provide different nice features like prompt caching, injecting variables into your prompts. You can do A/B testing, and also you can do evaluations in the same platform. Let's talk about the agent and prompts evaluations. It all starts with the different approaches how you can do that, and the most popular one is LLM as a judge. It is basically a very simple approach. You just ask another LLM. You provide some kind of interaction or question and ask another LLM to give a score. And yeah, this way, if you have a nice uh, that data set, you can gather your average and get some number back. Another popular metrics are question answer generation and DAC and GEVAL. And there are a lot of different metrics for all the different parts of your pipeline. It's all very complicated. And for example, for the RAG solutions, you have to measure and evaluate separately your retriever part and generator part. For agents, there are different set of metrics. Also, you have to measure safety metrics like I don't know, PI leakage, things like that. But luckily, there are a lot of different useful frameworks. The most popular ones, I believe, DeepEval and Regas and PromFu, which quite easily allow you to start, evaluating your prompts and agents. The most of these metrics are based on the GEval um, paper. Basically, what it does, the approach is describing to you first have to generate like a series of steps for chain of thought prompting. Then you concatenating all these into one big prompt with all different parameters. Using LM as a judge, you are asking to generate a score and then normalize the score and take the weighted summation. So this is how it works. Then there is a very big topic regarding LM, about the LM benchmarks, because in my opinion, when you're building a particular agent, you have to understand what is the best LLM for your use case, for your agent you have to use, because some models are better in I don't know, better in coding. Another model is better in creative writing or role play. So there are a lot of different benchmarks, like the most popular ones, MMLU, I believe, Human Eval. These are all like academic benchmarks, but there are also a lot of newer approaches. I believe these websites, like Artificial Analysis, LLM Arena, Walls.ai, the most popular companies that are doing LLM evaluations and benchmarking LLMs. Um, but there is, for example, a leaderboard where a startup they're trying to build a trading agent, and they just and it turns out that Grok 4, for example, is much better in trading than other models. There is also a Terminal Bench, a very popular benchmark for the software developers, in my opinion, because it is evaluating terminal-based coding assistance with different models. Another interesting idea is if you go to any Reddit group where people talking about vibe coding and these terminal-based coding agents, uh, you can notice a pattern. Every time new model drops in, everyone is so excited about it, and people are sharing their um, uh, like prompts where a model was able to build the whole solution just from one shot. But couple weeks later, people yelling and complaining that model right now is not able to do almost the same thing anymore, and they're claiming that probably companies are nerfing this model. Maybe instead of serving full model, they're using quantization, where they it's kind of like providing less capable model with a low precision weights. And I was always curious because I also feel that and notice that, and I was always curious: is it just me, or maybe everyone else is actually right? So this is shameless plug. We built that together with Victor. Website is at nerve.org. Idea is very simple. We are continuously running evaluations against, in this particular case, Claude anthropic models. And it turns out, indeed, there are periods when like the numbers we are getting back from our evaluations are different. And for example, yesterday, no, the day before yesterday, there was an incident on the Anthropic side, and as you can see, the failure rate for these models was much higher. So indeed, it can happen. But in my opinion, these companies are probably not, breaking their SLAs. They're serving the same model all the time. In reality, what happens is that we are dealing with the bugs and issues at the infrastructure and inference tooling side. Like, for example, last year there was a big incident, and Anthropic provided information why that was happening. And indeed, it was some misconfiguration in TPU servers, some compiler bugs, and some issues with the load balancers, which were using different settings for different models. So, yeah. And yeah, next is compliance and audit. Again, showing you example from the Langfuse, where you can gather all the logs and other safety related and ethics related things in one platform. Um, Next, also very big topic is drift detection, because like in traditional ML, there are different types of drift and a lot of different approaches how to deal with it, how to detect it. It becomes even more complicated with the agents, because I found this paper. They're introducing new types of drift, where your agent, for example, can degrade in terms how it is establishing goals for itself, or maybe in multi-agents environments, drift can happen between the in agents collaboration. So in reality, you probably have to gather some metrics and monitor performance in all these steps. Next is AI contracts. So this is new for me. I never heard about that. So I did some searching, and this is about companies, LLM providers like and these AI labs, establishing some kind of frameworks and guidelines for their partners and clients. So, for example, there is an OpenAI practices for governing agentic AI systems paper. They define in this framework how you should integrate LLMs and agents in your workflows. And there is an example how Palo Alto Networks use that to build a procurement agent. And um, basically, TLDR is that they're saying that it used to be when using traditional ML to make decisions, the responsibility usually at the last step. Your model produce some output and human verifies it, and all the issues with the bias and ethics. Usually, uh, that means that you have to add more training data to your traditional model, retrain it, and it should be good. But with the agentic systems, now these agents call tools. They execute in these multi-step workflows. They can talk to other agents, and these acts they can span across different boundaries within the companies and can take more time. So now companies have to also um, monitor these actions as well. So that makes that accountability more complex. And these AI contracts helping companies with that. Maybe not avoiding these issues completely, but at least have some framework and monitoring in place so you can act if something goes wrong with your AI agent. Next, advanced contractors. This is about kind of similar to the previous AI contract topic, but this goes into details how you can formalize relationships between users and AI systems like SLA. And author extracts names for main steps, which are formalized contract. Basically, this is a very big prompt where the creators of such agentic AI system, they trying to include as many different use cases, edge cases, information as much as possible. So agent can always refer to that document. Then you have to build in feature that will allow agents to flag risks if they see something, if they notice something during they work. Another thing is um, you have to give your agents ability to self-validate and correct themselves. This is usually just an internal loop, which is on every step ask agent to verify and double check information. And the last pillar, how author called it, is hierarchical decomposition, and this is reminds me first chapters in the book where we were reading about the prompt chaining, routing, and parallelization patterns. Um, all that information reminds me about the compounding engineering plugin that I'm currently using in my daily job. This plugin is basically a set of different prompts, different skills for Claude Code, but it also there are versions for other CLI coding agents, and we can see some similarities between how in those formalized contracts we have, for example, this last step, decomposition via subcontracts. In this plugin, you have different sub-agents. So when you ask to code something, the plugin will divide your work into the smaller pieces and assign a specialized agent for every piece. Like for example, front end changes will be performed by an agent which is skilled in that particular work, etc. When you are asking your coding agent to review changes again, it will the work will be divided into the sub agents that will do, for example, security research, like best practices for this particular language, research how your final code is following, guidelines and style, etc. All right. Next, anomaly detection. Um, this is simple. You're basically tracking errors, um, and possibly if you're building publicly faced, agents, people will be trying to hack your chatbot, and that can be bad for the business. So you have to track these attacks, malicious prompts, things like that. An interesting point is that you better track emergent behavior in your agents, um, because today is very popular, that OpenClaw framework, where they built like a framework allowing you to run agent on your machine without any restrictions, and it can um, not just connect different external data sources, but it can also modify its own code. And people are sharing hilarious stories about how they asked this OpenClaw bot to do something, and it was able to like pull documentation, encode that ability, so it can now, for example, send you message in Telegram um, or things like that. Another person from the internet ask um, ask its agent that they noticed that there is a .env file with all the API keys, etc., um, in that virtual machine where that agent was operating. So they asked to remove it because this is not a best practice to have it. And agent, it's kind of an example of emergent behavior. Instead of fixing the problem, agent just revoked access to that machine from user because it doesn't want user to double check what is it doing there. That was funny. Next, we talked about the LLM evaluations and benchmarking, evaluating agentic systems. Is another topic. It just adding more and more additional steps, and complicating system even more, because you have to examine reasoning, tools usage. You have to have these eval sets, which, for example, have interactions. like um, for example, if you build a chatbot which specialized in answering only, let's say, financial questions, your ideal conversation, it is nice to have an ideal conversation interaction between user and agent in your eval set. So you can run it and compare it with your latest prompts or latest agent versions, for example. And there are different ways how this evaluation and matching works. For the high stake scenarios, you probably would like to have exact match, but for some simple chatbots, any order match will probably be fine. Uh, and again, if you have multi-agent systems, it's an additional layer of tests and metrics because you would like to know how efficiently they cooperate together. And if you would like to add more agents to work on one task, is it actually be better for performance or not? You will not be able to answer this question without establishing proper evaluation and monitoring framework. That's it. Any questions regarding the chapter 19? All right. Chapter 20 is pretty straightforward. It is about prioritization. If you are building a truly autonomous agentic systems, quite often you need some tasks to be executed faster than other tasks that allow you to avoid delays, again, improve user experience. And a use case, an example can be probably for the self-driving, for the self-driving, if your car is detecting some kind of obstacle on the road, you definitely want to prioritize steering instead of, scanning something on the side of the road. Um, and the implementation of such prioritization is again pretty simple. First of all, you have to establish different criteria like urgency, importance, maybe cost benefit analysis. Uh, the common way to assess your tasks again these criteria is using LLM as a judge. And then, based on the output from that judge, you just put in all these tasks into a queue and assign different priority levels to each tasks. So then your workers, again, this reminds me priority queue pattern from the traditional software development. And then your workers, in your case, in our case, AI agents can pull these tasks and process them according to the priority. And here's your example how very simply it can be implemented in with the Llama Index framework, which I really like. In this example, um, we just assigning giving scores to different tickets in your backlog using LLM as a judge, assigning the role of the senior engineering lead. So then we can rank these tasks and process them in the right priority order. That's it. Any questions? Cool. Thank you.
All right. Yeah, and thank you for presentation. So if we don't have any questions, then Yeah, lovely. We have only 2 chapters left in the official book, and we also have an appendix. So I guess I'll message you guys asynchronously on Telegram and Discord with the schedule. So probably, I guess I'll have to take a look at the chapters. Probably it's going to take us another 2 meetings to cover them, but maybe it's going to be another 1 meeting. I'll take a look to see which one of them makes sense to cover. So yeah, let's stay in touch, and it's going to be, well, definitely we'll wrap this up next week. So yeah, stay in touch, and thank you, Anton, for presentation.
Sure.
And I'll